So here in the next examples, we're determining if the given function satisfies the hypothesis of the mean value theorem on the given interval, and if so, we'll find all c values in the interval that satisfy the conclusion. So the two hypotheses we must check off first is that f is continuous and differentiable. Well, f is a polynomial, so I know that it's continuous and differentiable. So f of x is a polynomial, so it is continuous on the closed interval and differentiable on the open interval. So now what are we going to apply? The mean value theorem. We've just checked the two hypotheses, so by the mean value theorem, there exists a c value within this open interval 1, 4, such that f prime of c, the slope of the tangent line at c, is equal to the slope of the secant line that we can draw in between those two endpoints. So now that I've set up that this mean value theorem can be applied by checking off the two hypotheses, I've stated the conclusion, which now creates an algebraic equation I can solve for c. So first, let's look at the left side. What is f prime of c? Well, f prime of x is 2x minus 1, so f prime of c is going to be 2c minus 1. And then we need to figure out what is f of 4. F of 4 is 12. F of 1 is 0. And then 4 minus 1 is 3. And then 12 minus 0 divided by 3 leaves 4. So I have 2c minus 1 equals 4. Now I have a very simple equation to solve. 2c equals 5. C equals 5 over 2, which is an element of that open interval. So you always have to check, is that c value in my interval? Yes, it is. So this c value tells us that f prime of 5 over 2 equals 4. So c value equals 5 over 2, which is in that element, and that is an element of that open interval. All right, so let's try the next example.